All right, Honors Algebra 2 and Algebra 2. Here is that Spring 2020 Final Exam Review Guide packet. I think it's the last one that is in Skyward. Again, 11 very easy assignments because 99% of the answers are available in these videos. And I have sent all the classes emails telling them how many they have to complete in order to not be on the incomplete list. That would be a shame to get on the list because you simply don't want to do anything. Write out the instructions, folks. If you don't label this, don't number this, I can't read it. I'll email you back and ask you to do it again, so do it right the first time. Number 1 through 2, 1 and 2, simplify, no negative exponents. There is the question right there, and then you just multiply, add the exponents. Negative exponent means it moves on south. Again, this is all a review over the second semester, so I'll go through this relatively quickly. Divide. 144 divided by 9 is 16. 9 more x's up top, 5 more y's down below, 7 more z's up top. 3 and 4. Simplify. There's number 3. Write all those out. Combine like terms. 13x squared plus 3x plus 37. Number 4, just distributes. Distribute. X goes to 2x squared, goes to negative 3x, goes to 5. Then it's the 5's turn. Then combine like terms to get that. All right, this is probably broken into a few videos, I would imagine. Anyway, I think 77 total questions, 20 points in Skyward. Divide everything by 6 and take 2 away from the exponent when we're talking about that base of x. State the degree and the leading coefficient of both those, 6a and b. All right, highest power is the degree, 3. Leading coefficient is what's attached to that x to the third. And b, it is written in standard form, highest to lowest exponent, degree 3, leading coefficient of negative 3. All right, moving on. Yes, on 7a and b, I want you to draw the curve. State the number of real zeros and describe the end behavior of the graph. Yes. Do you draw that curve? Make that curve like that. I think that meant draw these. You can curve those if you want. Anyway, opposite direction for those arrows means it's an odd degree function. 1 real 0 crosses the x-axis 1 time. On B, notice that the arrows go in the same direction. That means it's even degree function. It crosses the x-axis 4 times, 4 real zeros. On 8 through 10, we're going to factor completely. That is the sum of 2 perfect cubes. You take the cube root of both, and you square the first term. Opposite sign, the inner product, you square the second term. Multiplies 42, adds a 13, 7 and 6. Instead of it being x plus 7, x plus 6, it's going to be x squared and x squared there. On 10, what do they have in common? They have an x in common. Factor out the 10. Well, it multiplies to 16 and differs by 6. An 8 and a 2. The 8's negative because the middle term is negative, so the bigger factor is negative. That's how it factors. On 11, write a polynomial of least degree, which has the given zeros. So x equals 0, x equals negative 5, and x equals 3. That means x plus 5 would be in a parenthesis, x minus 3 would be in a parenthesis, and x minus 0, or just x, would be all by itself. What I did is a little foiling. I don't know if you can hear my daughter upstairs. First outer, inner, last. Leave the x on the outside. Simplify that and multiply everything by x. All right, there we go. Page 2 in the history books there. Solve by factoring. Number 12, what you're going to do, again, you're going to write out the entire problem. You're going to take out the x that they all have in common. You're going to factor this. Well, multiply 6 through, differs by 2, x minus 9, x plus 7. Cover up method, x equals 0, x minus 9 equals 0, and x plus 7 equals 0. Those are your 3 solutions. Number 13. What multiplies to 20 and adds to a negative 9, negative 4, negative 5. X squared minus 4, x squared minus 5 is 0. That's what we got there. X squared equals 4, x squared equals 5, x is plus or minus 2, x equals plus or minus root 5. All right. What multiplies to 81 differs by 0. No middle term there. X squared minus 9, x squared plus 9 equals 0. So x squared equals 9 or x squared equals negative 9. We get x equals plus or minus 3. X equals plus or minus 3i, because you're going to take a square root of a negative. Got to have the I there. For 15 through 17, given f of x is 5x plus 9 and g of x is 3x minus 7, find on 15 f plus g of x. That's f of x plus g of x. So take f of x, which is 5x plus 9, and add it to 3x minus 7. There you go. F of x minus g of x is 5x plus 9 minus all of 3x minus 7. Make sure to put in parentheses. You get 2x plus 16. F times g of x, that's f of x times g of x. So 5x plus 9 times 3x minus 7. Foil that up. There we go. On 18, identify the domain and range of each function. With the square root function there, I can take the square root of 0, but nothing less than that. Square root of a negative, I can't graph that in this class. It's going to give me an I of some sort. So you set what's inside the square root equal to 0, get x equals 7. The domain is x is greater than, any x greater than or equal to 7. Now that 8 is involved with the range. When I plug 7 in for x, I get 0. The square root of 0 plus 8 is 8. 8 is the smallest y value you'll have. So the range is y greater than or equal to 8. We were able to do that in class together. Set x plus 4 equal to 0. The domain is x is greater than or equal to 4. That means the range is y is greater than or equal to 3. I'm going to try to make each of these videos for this last assignment about 10 minutes each, so we'll probably cancel. We'll probably stop this video at the end of this page. Given f of x is x squared plus 6 and g of x is 5x minus 7, find f of g of 2. That means you figure out what g of 2 is first, okay? Plug that into the g of x equation there. 5 times 2 minus 7 is 3. Then you plug 3 into that outer function f. That means you're going to square 3 and add 6. That is a composition. G of f of negative 3, figure out what f of negative 3 is first. Plug negative 3 into that equation right there. You get 15. Plug 15 into g of x. 5 times 15 minus 7 is 68. G of 1, that means you figure out what g of 1 is. Plug it in right there. You get negative 2. And then you plug negative 2 back into g. 5 times negative 2 minus 7, negative 17. 22 and 23, find the inverse of each function. Remember we talked about the family swap there. X and y switch positions, so x equals 5y minus 2. Then I want to free that y. Add 2 to both sides, then divide by 5. Y is x plus 2 over 5. Same thing there on 23. Y equals the square root of x minus 1 plus 2. That x, that y switch places. Switch spots, x equals the square root of y minus 1 plus 2. Subtract 2 from both sides. And then, if I want to free up that y, I need to think about what the opposite of square root is. I'm going to square the inverse, the opposite, the exact opposite operation there would be squaring both sides. X minus 2, parentheses squared equals y minus 1. Add 1 to both sides, and there you go. 423. There's an imaginary 2 on the outside. Well, the square root of 100 is exactly 10. 2 goes into 16 8 times exactly. 2 goes into 24 12 times exactly. Taking the third root of 64. 4 times 4 times 4 is 64, so it's 4. 3 goes into 12 4 times exactly. 3 goes into 27 9 times exactly. Something that's going to have a little bit of leftover is number 26 here. The square root of 50. How do you make 50? It's 5 times 5 times 2. So the pair of 5s break out of that radical jail, but the 2 remains in there. 2 goes into 7 3 times with 1 left over for the x's. 2 goes into 13 6 times with 1 left over for the y's. Folks, that is a good spot to stop at. So we're going to make this exactly 10 minutes long for this first video. The final exam review guide. Yak Math video assignment.